So in the last video, we talked about loosely how to find the slope of a curve. And we really just looked at one example, y equals x squared. And if you recall, the key idea was after doing all the algebra, we had this delta x. I said, well, let's make delta x so small we can forget about it. Now, let's formalize. What do we mean we can forget about it? And this is where the idea of an infinitesimal comes in. So I will say that the number epsilon is infinitesimal. And we'll get some symbols to speed this up, but right now I'll spell it out for you. So infinitesimal if it is bigger than every negative number and smaller than every positive number. So it's for all a in the positive real numbers. Right? So epsilon is an infinitesimal if it is smaller than every positive number, positive real number, and bigger than every negative real number. And we're not going to count 0 in there. So question is, can you tell me any numbers that are smaller than everybody and bigger than every negative number? Hopefully the example that you can think of is that 0 itself is an infinitesimal. Now, in the real numbers, it's actually the only infinitesimal. Because if I had some other number, so if let's say epsilon isn't 0 in the reals and an infinitesimal, well, it doesn't matter. We can show that it's not infinitesimal because epsilon, so if epsilon's a number, then epsilon divided by 2 is definitely going to be less than epsilon itself. And if epsilon's a real number, and I divide it by 2, it also is a real number. And so this cannot satisfy this above definition up here. So 0 is our only infinitesimal in the reals. But in the previous section, I said I wanted to talk about numbers being so small we don't, we can ignore them. And so we can do exactly that by adding numbers into the real number system. So we're going to just add these infinitesimals. So we're going to extend it, and the hyperreals, the set of hyperreals, and we'll denote it by R. So we're still using the symbol for the reals, but now I'll put a star on it to say it's been augmented. And so this is going to be all the reals along with infinitesimals. And we'll actually see a whole bunch of stuff. But to make it algebraically closed, we'll have a whole bunch of other things. But right now we can think of this new set. R star is going to have all the reals. It also has all the infinitesimals. So just for notation wise, because we're not going to be, you've never met an infinitesimal before. You've never studied such a thing in another class. So we're going to just introduce some notation. So notation here, so some symbols we'll use to denote infinitesimals. Will be symbols like epsilon. I'll also use delta. delta x, maybe delta t, so on and so forth. So I will reserve epsilon and delta symbols by themselves to denote a infinitesimal, as well as this combination, delta x, delta t. So unless otherwise stated, if you see an epsilon, you see a delta x, a delta t, or a delta y, something like that, we are talking about an infinitesimal. So it's something that satisfies this above relationship, that it is bigger than every positive real number, or sorry, smaller than every positive real number and bigger than every negative real number. And just like the real numbers, an infinitesimal can be positive, it can be negative, and in the one case it can be real. So epsilon can be positive. So in that case, epsilon is bigger than 0. It can be negative. Epsilon can be less than 0. And then it can be real. But if it's real, as we talked about, the only example is that epsilon is exactly 0. So epsilon, or an infinitesimal, can be positive, negative. And infinitesimals, so now we can add infinitesimals to real numbers. So a hyperreal is anything of the form, I don't know, a plus epsilon, where a is a real number, so a is real, and epsilon is an infinitesimal. Right? So hyperreals look like a plus epsilon. So examples like 7 plus epsilon, or pi plus delta x. These are hyperreals, and I would say that 7 plus epsilon is infinitely close to 7. And what do I mean by that? Well, 7 minus 7 plus epsilon, well, that's pretty simple. 7 minus 7 is going to be equal to negative epsilon, and it is an infinitesimal. So we'll say that two numbers, a and b, are infinitely close. So two hyperreal numbers. So if a and b are hyperreal numbers, right, remember that notation. If a and b are hyperreal numbers, we say that they are infinitely close. A and b are infinitely close, and we'll say A is infinitely close to B, if A minus B is an infinitesimal. So we're going to have to get practice at determining whether a number is an infinitesimal or not, just by its characteristics and whatnot. But that's something we'll investigate quite extensively in the next section. But let's get kind of a model for the hyperreals. Remember, the real numbers we can put on a line, and the hyperreals also we can stick them on a line. So we have the real line as we're used to, and it goes on forever. And then we have all the infinite numbers, and then down here, right, the real line goes on forever, and down here we'll have the negative infinite numbers. So maybe right here is 0. And the question is, well, how do we see these infinite numbers? So the book talks about this, and the idea of using an infinite magnifying glass, if you will. And so if I looked at 0 and I were to put a magnifying glass there, an infinite magnifying glass. Say I would, so I'm zooming way in, and I've got the number line here. I should have made it yellow, I guess. It doesn't change color when you zoom in. So I've zoomed way in, and 0 is still there. I can see it, but it's such a powerful microscope that I can also see other infinitesimals. So there's epsilon and negative epsilon, and maybe 3 epsilon over here. So I've got all the infinitesimals. They're all close to 0. They're packed in there close to 0. We also have, maybe if I look over here at the value, let's say this is, I don't know, 10. And I could take again my microscope, my infinitesimal microscope, and zoomed in to that region. Again, zoomed in, I would see the line. I'd still see 10. Right? 10 still is there, but I also see next to it 10 plus epsilon. So it's a hyperreal. It's infinitely close to 10, but it's not equal to 10. It's nudged away by this little amount, and I would also have 10, say, minus epsilon. So in the next section, we'll talk about what's over here in the infinite value.